Okay, so next topic is even and odd function. Okay, even and odd function. Now actually simple thing. First find f minus x. If this f of minus x is equal to fx, then fx is said to be even function, and if f minus x is equal to minus of fx, then this become odd function. Okay, so simple thing now, I am just writing directly. Okay, so see, if f minus x is equal to fx, it means if you are replacing x with minus x but we are getting same function, then function is even function. Okay, for example cos x, if you replace x with minus x, then also we are getting same thing cos x. Cos minus x is equals to cos x, so cos x is even function, is an even function. Similarly, if you are taking x square, y equals to x square, if you replace x with minus x square is also equals to x square, then again this one is even function. Okay, like this one. So if f minus x equal to fx for all x belongs to domain of f, okay, this must be satisfied for all values of x from domain of f. Okay, if f minus x equals to fx for all x belongs to domain of f, then fx is even function. Okay, and if f minus x is equals to minus of fx, if equals to plus fx, then even if minus of fx for all x belongs to domain of f, then fx is odd function. Okay, so it is clear. If f minus x equals to fx, then even function. F minus x equals to minus of fx, then odd function. Okay, so for example, if I am taking fx equals to x square, put x as minus x, we are getting same value. Minus x square is also equals to x square now, so this one is even function. Okay, do you have any other example for even function such that we are replacing x with minus x but we are getting same value, like cos x or anything else, mod x? And this one, if you replace now x with minus x, again you will get same value now, mod of minus x equals to mod of x. Okay, so both are even function. Okay, na, these are even function. And now do you have some example for odd function such that when we are replacing x with minus x, then we are getting minus of fx? Okay, tell me anyone now. Okay, suppose first one I am taking fx equals to x cube. Obviously this one is odd function. Okay, now if you replace x with minus x, what we are getting? Minus of x cube. Okay, it means minus of fx. Any other? Fx equals to x, this one is also odd function. Sin x is also odd because sine of minus x is equals to minus of sin x now, so odd. Tan of x is also odd function. Okay, so these are odd function. Okay, so these are the example of even function and these are the example of odd function. These functions satisfying this one and these functions satisfying this one. Okay, now if you draw the graph of even function of these, okay, just draw the graph of these two functions, fx equal to x square, this is the graph. Okay, na, y equal to x square, fx equal to mod x, this one is the graph of y equals to mod x. Okay, if you see both function, then these graph of these function are symmetric about y axis. Okay, na, these are symmetric about y axis now. This one is x axis, this one is y axis. Okay, y axis symmetric about y axis, it means you will get same graph on both sides. See na, same graph, this one and this one side. Okay, na, we have same graph on both sides. If you have same graph on both sides, then function is symmetric about y axis. Okay, na, we have same graph on both sides of y axis, so this one is symmetric about y axis. Sometimes if you know graph is like same as above and below the x axis, it means symmetric about x axis, but at this time this one is symmetric about y axis. Okay, and if you draw the graph of fx equals to x cube, graph of fx equals to x cube, it means this is the graph na, in 11 this one is done. this is the graph of fx equal to x cube, y equal to x cube. And if you draw the graph of fx equals to x, it means y equals to x, then a straight line y equals to x. This one is y axis, this one is x axis, y axis and x axis. Now can you say that this one is symmetric about x axis? This is not symmetric about x axis. This will be symmetric about x axis if you have graph is like this one and this one, then same graph above and below. Na, this is not symmetric about x axis. Then this is symmetric about, actually this one is symmetric in opposite quadrant. We have same type of graph in first and third one, na? Okay, in first one and third one. Anytime if you have same type of graph or same type of shape of graph in opposite quadrant, it means this one is symmetric about origin. Okay. Suppose in second and fourth, if you have same type of graph, then symmetric about origin. Okay, not symmetric about x axis. So these graphs are symmetric about y axis. Okay, and these graphs are same in opposite quadrant in first, third, then this one is symmetric about origin. Okay na? If you want graph symmetric about x axis, then you will get like this one. Now this is the symmetric about x axis, same graph above and below of x axis, but this is not symmetric about x axis. Okay, so I can write this one as a note now, and remember this one, note, graph of even function is symmetric about y axis and graph of odd function is symmetric about origin. Okay, so graph of even function symmetric about y axis and graph of odd function always symmetric about origin. Okay na, right down. Can I rough? Now view properties of odd and even function, and remember these properties. Okay, these are useful. So properties of even and odd function. Properties of even and odd function. Okay, first property. Now actually in some question, only in some question, it is not easy to prove that f minus x equals to fx. Okay, we know the definition of even function is if f minus x is equals to fx, then function is even function. Okay, but sometimes easily we can't prove that f minus x equals to fx, but with respect to this one or at the place of this one, it is easy to prove that f minus x minus of fx equal to 0. Okay, again both are same thing. In this one f minus x equals to fx, if you put fx at this side, then we are getting minus of fx, it means same thing. From this one also I am getting f minus x equals to fx now. So sometimes it is easy to prove this one equals to 0 for even function. Okay, and for odd function this one is easy to prove. Okay, I will take an example based on this one. Okay, after that you can say that yeah, okay, this one is easy to prove. Okay, so this is the first property. Sometimes it is easy to prove f minus x minus fx equals to 0 for even function. Okay na, same thing. In this one f minus x equals to fx, it means even function, and f minus x plus fx equals to 0 for odd function. Okay na, actually sometimes if you can't write the f minus x easily in terms of fx, then try these. Okay, I will take an example based on this one. Now second property, Now if you any function, you can write any function in terms of sum of even and odd function. Okay, any function, second property, it is important. Okay, any function can be expressed as sum of an even function and an odd function. Okay, any function can be expressed as sum of even and odd function. How can we express? Okay, see one thing I have proved now. Okay, tell me one thing, that if I am writing a function fx plus f minus x, now check, can I say that this one is even function? Any function is said to be even if f of minus x is equals to fx. If you want to prove that this one is even function, or you want to check that, then assume this one as hx. Now if h minus x is equal to hx, then you can say that this one is even function. Okay, now check, if you put h minus x, then replace x with minus x now, then what we are getting, f minus x and f minus of minus x, then x. Okay, again we are getting same, it means h minus x is hx. So this one is even function. So actually for any function fx plus f minus x is always even, and fx minus f minus x, this one is odd. Okay, check, suppose this is hx. Okay, now find h of minus x. If you replace x with minus x, then we are getting f of minus x minus f of x. Okay, now check, can you write this one in terms of hx? Obviously, if you take common minus, what we are getting, fx minus f of minus x, that is equals to hx, so h of x. So h minus x equals to minus of hx, it means this one is odd. So actually for any function fx plus f minus x is an even function, and fx plus f minus x is an even function, and fx minus f minus x is an odd function. Okay now, okay. And now see, any function can be expressed as sum of even and odd function. So I am writing fx plus f minus x by 2 plus fx minus f minus x by 2. Okay, now check one thing, this one is even function or not. If you replace x with minus x, then what you will get, f minus x plus fx by 2, same thing. Okay, so this one is even function, and in this one, if you replace x with minus x, then you will get this one equals to minus of this one. Okay, so this one is odd function. Okay, so fx can be written as sum of even and odd function. If you solve this one, then you will get fx. See, clearly take 2 LCM, f minus x minus of f minus x cancel out, 2 fx by 2 equals to fx. Okay, so it is clear. Third one. Okay, for third point, take any even function, take any one in mind now, taking na any even function. Okay, now differentiate this one. Okay, differentiation is done. Now check this one is odd or not. Obviously now, if you take any other even function, again differentiate, again you will get odd function. Okay, now for example, choose any even function. Even function is f minus x equal to fx. So suppose cos x. Okay, cos x is even function now, because if you replace x with minus x, cos minus x is again equals to cos x. Cos minus theta equals to cos theta na. So this one is even function. Differentiate, what we are getting, minus of sin x, and this one is odd function. Okay, now take any other even function, x square, differentiate 2x. 2x is an even odd function. Okay, so differentiation of odd function is even, and differentiation of even function is odd function, and differentiation of odd function is an even function. Okay, if you are taking any odd function, suppose x cube is odd function now. then differentiation of this one is 3x square. Now put x as minus x, you will get same value, it means even function. Okay. Take any other odd function, suppose 10x. Differentiate this one, sec square x. Now if you put x as minus x, again you will get same value. Okay. So if you differentiate even function, then you will get odd function. If you differentiate odd function, then you will get an even function. Okay. So I can write now. If fx is an even function, then f dash x is odd function. And if fx is an odd function, then f dash x is an even function. Okay. So if fx is odd, then derivative is even. If fx is even, then derivative is odd. Okay. Simple na. So 3 points are done. Can I rough? I have remaining 3 points. Okay. Now for fourth. Now actually we know that if f minus x is equal to fx, then function is f minus x equals to fx, then function is even function. And if f minus x equals to minus of fx, then function is an odd function. Okay. Do we have any function such that which is both one even and odd at a same time? Okay. Actually we have fx equal to 0. Fx equal to 0 is the only one function which is both even and odd at a same time. Okay. See, suppose if you want to prove, then what do you want? We want any function which is both even and odd. Okay. So suppose fx is a function which is both. This one is both even and odd. If fx is even function, then f minus x must be equals to fx. And if fx is odd also, then f minus x must be equals to minus of fx. And what do you want? We want this function fx. These both are the value of f minus x na. So this f minus x can be written as fx. No problem na. So I am writing fx equals to minus of fx. By using these na, okay, both are the value of f minus x, so this one must be equals to this one. Now take minus fx at this side, 2fx equals to 0, fx equals to 0. So this is the only function which is both at a same time even and odd function. Okay. So remember this one. Actually na, sometimes if it is given that we have a function which is both odd and even function, it means then you can't then they will not give you the value of function that fx equals to 0. Then you have to consider that it means fx equals to 0 is the function. Okay. So which number of point? Fourth one na. Fx equals to 0 is the only function which is defined on entire number line and even and is even function as well as odd function, okay, at the same time. Okay na. So fx equals to 0 is the only function which is defined on entire number line and which is both even and odd function at the same time. Okay. Now fifth point. Now suppose if function is even function, okay, can I say that every even function is main even? Actually yes, because suppose if fx is even, then I can say that f minus 2 equals to f2. because definition of even function is f minus x equal to fx, na? Okay, this is the definition of even function. If fx is even function, then put value plus 2 or minus 2, you will get same value like this one, na? X square. Put minus 2, 4. Put plus 2, 4. Okay, so same value, na? F minus 2 equals to f2. So if your function this is like f minus 2 equals to f2, it means for these 2x minus 2 and 2, we have same image. For any 2x, if we have same image, then we have many one. If for 2x we have same y, then function is many one, na? Okay, so I can write. Every even function is many one. Okay, if you know that function is even, it means function is many one, directly you can say. Okay, sixth point. Now suppose fx is odd function and 0 belongs to domain. Okay, then f0 is always equals to 0. If fx is even function and 0 lies in domain, then value of f0 is always 0. Okay, so sixth point is, if fx is an odd function and 0 belongs to domain, then f0 is always 0. Okay, value of f0 is always 0. Okay, if you want proof for this one, then see. Fx is an odd function, so f minus x is equals to minus of fx. Okay, replace x with 0, then what we are getting? F minus 0, it means 0 equals to minus of f0. Then from this one we are getting that f0 equals to 0. Okay, so if fx is an odd function and 0 in domain, if 0 is not in domain, then how can you say that f0 equals to 0, because 0 is not in domain. But if 0 in domain, then obviously f0 is always equals to 0. Okay, now last point, then we will take question based on even and odd function. Okay, so seventh one. Fx gx. Now suppose if we know the about fx and gx, that these are even function or odd function, and we want information for fx plus gx, fx minus gx, fx into gx, like this one. So fx plus gx, for fx minus gx, for f into g, fx into gx, for fx by gx, and for f of gx. Okay. Okay, suppose these are. Now if we know that fx is either even or odd, and we want for this one minute. So how many possibilities? If both are even, fx is even and gx is odd function, this one is odd, this one is even, and both are odd. This is the only possibility now. Okay, so I am taking all. Now suppose if fx and gx both are even, then can you identify that fx plus gx is even or not? 1 minute, easily we can check. Any function is said to be even if f minus x equals to fx, and odd if f minus x equals to minus of fx. So just find out by putting x as minus x. Okay, so see, if you want to check for this one, then I am considering this one as hx, another new function, sum of two function fx plus gx. Suppose this is equals to hx. Now I want to identify that if both are even, then this one is even, odd, or neither even nor odd, because it is also possible. So first find h of minus x. h of minus x, replace x with minus x. What we are getting? F of minus x plus g of minus x. Now fx is even for this case. Fx is even, then f of minus x is fx. Gx is also even, then g of minus x is gx. Okay. Now see, this is equals to hx. So h minus x equals to hx, it means h is even function. Similarly, if you replace x with minus x in this one, then f of minus x, g of minus x. F of minus x is equals to fx because fx is even, and g of minus x is again equals to g of x because gx is even. So this one also you will get even function. Okay. Similarly, if you want for this one, then again see, I am assuming this one as hx, fx into gx. And for this one, when both are even, I want to identify that this one is even or odd. Replace h with minus x, x with minus x, then here we are getting f of minus x, g of minus x. F of minus x equal to fx because fx is even function, and g of minus x is equal to gx because gx is also even function. Okay, then again we are getting hx, so this one is even. So similarly you can check for anything. So this one is also you will get even function. Now finally, if you want to check for f of gx, that is also even. Okay, I can proceed. So I want to check for f of gx. Okay na? Okay. Now replace x with minus x. If you replace x with minus x, what we are getting? F of g of minus x. Okay. Now f of g is even. See na, g is even function. So g minus x is equals to gx. Okay, and this one is equals to hx. So done. So h of minus x is equals to hx. So this one is also even function. Okay, so simply we can find. Now see, if fx is even and gx is odd, this one is even, this one is odd, then can you find for fx plus gx? Check. Okay, identify this one is even or odd. Pause and identify. Get it? Okay, what you are getting? Even or odd? Actually neither even nor odd. Okay, see, suppose I am taking this one as hx, gx plus fx. Now here fx is even, gx is odd, so find h of minus x. Then what we are getting? G of minus x plus f of minus x. Okay, now gx is odd, then g of minus x is minus of gx. Fx is even, so this one is fx. Now can you write this one in terms of hx? Actually no, this is not equals to hx na, and also this is not equals to minus of this one. So you can't write h minus x in terms of again hx. If you can't write, then this is neither even nor odd. Okay, so this one is nino. It means neither even nor odd function. Okay, similarly if you check for this one, then neither even nor odd. If you want to check for fx into gx, then can you identify fx into gx is odd or even in this case? If one function is odd and one is even, then product and division both are odd. Okay, see, suppose I want to check for this one. So hx is equals to fx into gx. Okay, now put x as minus x, then this one is f minus x and g minus x. Now fx is even, so fx, and gx is odd, so minus of gx minus outside, and this one is gx. Now fx into gx is hx, so what we are getting? Minus of hx. Okay, so h minus x equals to minus of hx, so this one is odd function. Similarly you will get this one as odd function. Now what about f of gx? Odd or even? Actually this one is even, not odd. Okay, see again how. If you want for this one, so suppose hx is equals to f of gx. Now replace x with minus x, because this is the only way to find that this one is odd or even. So f of g of minus x. Okay, now g of minus x, g is odd, so this become minus of gx. Now f is even. If f is even, then f of minus x can be written as simply fx, because f is even now. So h minus x is equals to hx. It means this one is even. Okay, so similarly you can identify for all. Okay, so now I am writing directly. If one is odd, other is even, then sum is neither even nor odd. No. Okay, this one is also neither even nor odd. Okay, fx into gx is odd. This one is also odd. This one is even. In this case, if both are odd, then the sum is odd. Difference is odd. Product is even. Product, how we are getting product as even? Because both are odd now. So you will get 1 minus from this one, 1 minus from this one, then minus minus become plus. Okay, for that reason. Similarly, this one is also even, and if f and g both are odd, then this one is odd. So for composite function, remember one thing. If at least one function is even, if both are even or any one is even, then composite function is even. If both are odd, only then this composite function is an odd function. Okay, if you want proof in this case, then see. Again, I am assuming this one as hx equals to f of gx. Okay, now h of minus x equals to f of g of minus x. Okay na? Now see, I want this one in terms of f of gx. G is odd function, so minus outside, minus of gx. Now f is odd function. If f is odd function, then f of minus x is equals to minus of fx. Okay, again minus f of gx is equals to hx. So h of minus x equals to minus of hx, then this one is odd function. Okay, done. Okay, so this is theory. Now we will take example. Always you will get simple thing for even and odd function. Okay, this one is easy now. Can I rough? But remember these properties. Okay, maximum time you will get directly based on property or a simple question. Okay. Now see, write a question. Classify the functions as even, odd, or neither even nor odd. Okay, so first function fx equals to x tan x plus cos square x. Okay, now you want to identify that this one is even, odd, or neither even nor odd. Okay, now if even, if f minus x equals to minus of fx, odd if f minus x equals to minus, sorry, even if f minus x equals to fx, and odd if f minus x equals to minus of fx. So I am finding f minus x. If this is neither equals to fx nor equals to minus of fx, then neither even nor odd. Okay, if you replace x with minus x tan of minus x and cos square minus x, minus outside, minus minus become plus, x tan x and cos minus x equals to cos x, this become cos square x. So this is equals to fx, so this one is even. Okay, even function. Second one, actually for this one also directly you can find. See, first identify for, okay, for this one if you want another method, then fx is equals to x tan x plus cos square x. Do you know about x? X is even or odd. This one is odd. Okay, tan x is odd function. Product of two odd function is even function. So this one is even function, and cos square x is also even. Okay, if fx and gx both are even function, then fx plus gx is also even function by using last note now. Okay, last property, so even. Okay, simply you can check. Any problem? If fx and gx both are odd, then product is even. Sum of two even function is always even function. Okay na? Okay. Now second one. Fx is equals to ln of 1 minus x by 1 plus x. Okay, find out for this one. Simply we can find out, just find f of minus x. So if you are putting x with minus x, what we are getting? 1 plus x by 1 minus x. Now can you write this one in terms of fx? Easily we can write. Can I write this one as this one in terms of this one? This one power minus 1. This is opposite of this one, no? So I can write this one as ln 1 minus x by 1 plus x power minus 1. Opposite of each other, na? Minus 1 outside, then minus of ln 1 minus x by 1 plus x, then minus, this is equals to fx. Okay, f minus x equals to minus fx, so odd. Okay, third one. Third one is fx equals to x square. X belongs to minus 2 comma 2. Okay, now this one is even. For every f minus x equals to fx. For every x belongs to minus 2 comma 2, we have f minus x equals to fx. This one is even function. Okay, actually why I am taking this one? Because of one reason. At this time we have same in domain, we have same value of x for positive and negative. So this one is even function. If you draw the graph of this one, then what you will get? Like this one. Fx equals to x square for minus 2 to plus 2. Okay, so graph is symmetric about y-axis. Okay, no problem na. For any x, if you take negative, then for that same, for positive x also we have same value. Okay, now but suppose if it is given that fx equals to x square and x is only belongs to minus 1 comma 2. Now this is not even function. Okay, see in this case this one is not even function. Okay, this is neither even nor odd. Okay, why? I have a reason. See, because here f2 or f3 by 2 is equals to 9 by 4. Now do you have f minus 3 by 2? Here you can't put f minus 3 by 2 na, but f minus 3 by 2 is not defined. Okay, at 3 by 2 you can find the value because 3 by 2 in domain, but minus 3 by 2 minus 1.5 is not in domain. So this is not even function because this must be true for all x belongs to domain. If 3 by 2, f3 by 2 is equals to 9 by 4, then f minus 3 by 2 must be equals to 9 by 4. But there is no value of f minus 3 by 2, then this is not even function. We have definition that f minus x equals to fx for every x belongs to domain. Okay, and also if you identify by using graph, then see, if you draw the graph, fx equals to x square only from minus 1 to 2. So this is minus 1 open interval because and 2. Now check, this is symmetric about y-axis or not? No, actually this is only symmetric in this region. After this one there is a graph, but there is no graph. Okay, so this is not even function, remember. Okay na? So in even function, if you same, we want same reason, same value of x for positive and negative in domain. Okay, otherwise this is not even function. Okay, done na? Remember. Okay, fourth one. Fx is equals to x cube plus x plus 1 by x square. Okay, now find for this one. Just put x as minus x, f minus x, f minus x, replace x with minus x, what we are getting? Minus x cube minus x plus 1 minus x square is x square. Now can you write this one in terms of this one? Actually no. If I take common minus, but also this is not equals to this one now, because now this plus 1 become minus 1. Okay. So this is neither equals to fx nor equals to minus of fx. So this one is neither even nor odd function. Okay, this is not both. Fifth one, fx is equals to 2 power x plus 1 whole square by 2 power x. Now check for this one. Again f minus x. If you replace x with minus x, 2 power minus x plus 1 whole square by 2 power minus x. Okay. Write this one as 1 by 2 power x. Take LCM, what you will get? 1 plus 2 power x square. In denominator, what we have? 2 power x. Square of that 2 power x square in denominator. Multiply with this one. Okay. 1 x cancel out. Then what we are getting? 2 power x. Okay na? Just convert. It is clear. If you put this one as 1 by 2 power x, 1 by 2 power x, then at the end you will get this one, and this is equals to fx. Okay. So even. Now I am taking final example which is based on first point. First point is sometimes it is easy to prove fx plus f minus x equals to 0 for odd function, and f minus x minus fx equals to 0 for even function. Okay. So see, last one. Fx is given as x by e power x minus 1 plus x by 2 plus 1. Okay. Now identify this one as even or odd function. Okay, try this one. Done. Now see, f of minus x, replace x with minus x by e power minus x minus 1 and minus x by 2 plus 1. Now check one thing, can you easily write this one in terms of this one? We can't write. Okay, but we want to check. See, first I am converting this one in terms of e power x. So 1 by e power x at this side, then in numerator. So finally what you will get? Can I write directly? Here 1 by e power x, then 1 minus e power x. E power x in numerator, here with minus sign. So if you multiply minus here, then what you will get? Then you will get e power x minus 1 into e power x. Okay na? Just simply put this one 1 by e power x and calculate, you will get this one. Both are same thing. Minus x by 2 plus 1. Again I can't say that this is equals to this one. Actually at this time this is not equals to this one. Easily I can't say. Now we have first point that sometimes it is easy to prove for even function, it is easy to prove fx minus f minus x equals to 0, and for odd function fx plus f minus x equals to 0. So first I am trying with fx plus f minus x, sorry, fx minus f minus x, because I know that function is even. So first and second. Now by using first minus second, fx minus of f minus x. Okay. Now this one minus this one, x by e power x minus 1 plus x by 2 plus 1 minus of x e power x by e power x minus 1 minus x by 2 plus 1. Now see, plus 1 cancel out. Okay. In these two I can take LCM e power x minus 1. And also I can take common x, then what we are getting? 1 from this one and from this one minus e power x. Okay. Plus x by 2 plus x by 2 is x. 1 cancel out. In this one take common minus, then e power x minus 1 cancel out. So this one is minus x plus x equals to 0. So if fx minus f minus x equals to 0, it means fx equals to f minus x. So this one is even function. Okay, done. Okay, in next part we will take composite function.